Building Technology. Group 001. Beka City Lecture Hall Redesign. We start with the problem analysis. This is a section of the lecture hall. During the winter, the lower part of the room is always very cold. Because of the height of the room, the heat is always pulled away from the parts where you need it. This is worsened by the heat loss through the badly insulated walls and the single plane glazing. During summer, the room becomes so hot that it can cause concentration problems and headaches. There's a lot of heat buildup that can't get away because of poor ventilation. The lecture hall has an acoustic problem as well. Very little of the hall is covered with sound absorbing materials. In fact, only the chairs are. The rest is very sound reflecting, causing echoing and eventually headaches. Furthermore, the ventilation ducts in place are quite loud, producing a constant hum during lectures. Continuing with the design directions, we are using the concept of an air chimney. This creates heat buildup over here. Because the hot air is attracted, an airflow is created. This also causes underpressure in the lower area of the room, which creates an airflow from fresh outside air through the room to the ceiling. Applied to our design, we would have the chimney be a part of the facade, creating a hot room at the top, warmed by the sun. This would cause a hot airflow from the ceiling to the roof. Simultaneously, it would suck air in from outside from under the chairs. For heating and cooling, we're following this diagram for ideal room temperature. Basically, this means warm feet and a cool head. Applied to our design, this means floor heating under the seats and floor, cooling from large air vents in the ceiling combined with the principle of phase-changing materials. These materials can absorb and store large amounts of heat. When room temperature drops, the heat is released again. We place them just above the ceiling to assist in additional cooling. The ceiling is made out of mechanical louvers. When closed, they block sunlight coming into the room from the transparent roof. When opened up, the sunlight will be reflected inside and the room will have natural light coming in. Furthermore, in the closed position, the louvers reflect sound into the room. This also happens to a degree in the opened position, but because of sound absorbent materials on the backside of the louvers, some of the sound is absorbed instead of reflected back into the room. In conclusion, we have a heat chimney for natural air ventilation. We use floor heating, air ventilation and phase-changing materials to cool from above. And with mechanical louvers, we control natural light and acoustic behavior.